We know that with traditional spanning tree protocol, the IEEE 802.1d standard, we had what was called a CST, a common spanning tree, meaning that all VLANs shared the same spanning tree topology. They had the same root bridge. All other switches used the same root ports. All the links had the same designated ports. All the same ports were blocking on our switches for every single VLAN. And then Cisco recognized that same topology might not be optimal for every VLAN we have. One VLAN might benefit from having one switch as the root, and another VLAN might benefit from having a different switch as the root, just based on the traffic flow patterns. And Cisco came up with PVST Plus, Per VLAN Spanning Tree Protocol Plus, where each VLAN could get its own spanning tree instance. However, we might have lots of VLANs configured on our switches. If we had a couple of thousand VLANs, we could run a couple of thousand instances of spanning tree, one for each VLAN, but another option is to use MSTP, and that's Multiple Spanning Trees Protocol, or you might also see this written as Multiple Spanning Tree Protocol, MST, and there is an IEEE standard for this. It's IEEE 802.1s, and here's the idea. Yes, different VLANs might benefit from different spanning tree topologies. However, a lot of VLANs might share the same spanning tree topology as their optimal topology. For example, let's say that in this very simple topology, switch A would be the best route based on the traffic patterns for VLANs 1, 2, 3, and 4, and switch B would be the optimal route bridge for VLANs 5, 6, 7, and 8. Well, instead of running 8 different instances of spanning tree, as we would do with PVST+, what if we did this? What if we said, if we break it down, there's really only 2 spanning tree topologies that we need. One that has switch A as the root and one that has switch B as the root. So instead of creating 8 different spanning tree instances, let's just create 2 instances, and that's what we've done here. We said in instance 1, switch A is the root. In instance 2 of Multiple Spanning Trees Protocol, switch B is the root, and we'll assign VLANs to the appropriate instance. We assign them to the instance that has their optimal spanning tree, so this is really the best of both worlds, isn't it? We're minimizing the number of spanning tree instances that we have to run while making sure every VLAN has an optimal spanning tree for that VLAN's traffic flow. That's a review of the theory of Multiple Spanning Trees Protocol. In our next video, we're going to take a look at its configuration.